No.
Okay, the text
It's
over
actually weak.
No.
was it take what?
Try using Liferim on this, it's gonna get you in trouble.
Yeah.
I'm just saying.
He was using it.
If I can get away with it, I'm gonna use it if it's explicit. But if it's implicit, you're not gonna see me doing it.
Implicitly on the key it was using.
If it's a book key, I don't defend the book at all. I use the book for ease, but I don't defend the book.
Alright. You shouldn't.
I don't. I think all math textbooks, when it comes to AP, are pretty crap. When it comes to a college level approach, pretty decent, but they put AP edition on it and they don't change
You
it.
should write your own AP now.
Yeah.
I give you one each time.
Unless you be
I'm on my way with that.
Get it published. Get it published.
Okay, guys, here are 6 trig derivatives, inverse trig derivatives that you need to know for my test. For the AP test, you will need to know arcsine and arctan. Now, they look at first really ugly. They do. And I gotta be honest, and I'm gonna be honest, which I am. These don't show up a lot, but when they, on the AP test. But man, when they do, are they easy. Just so easy. It's like pull out your freaking formula. But if you have no formula, there's nothing to pull out. Yes?
Can we store these formulas in like a Word doc on our calculator?
Yeah, but you can. But the problem is you're not going to see that question show up when you have your calculator out. You're going to see it on the non-calculator part. So they're not stupid at AP. I mean, it's a collection of people that have taught APCALC for sometimes 20, 30. There's a woman who taught it since the 70s. And she's really, really good. And there's also college professors and people that get together and they throw their thoughts together. They make a really good test. Like, I'm not one of those guys that is a proponent of teaching to a test. Because if you do that, you tend to leave a lot of the periphery off. But for this test, it's really good. So it allows you, I actually teach the curriculum and then I review towards the test, but I'm constantly telling you little things about it as we move through there, so you'll be really ready in May. But when you look at these formulas real quickly, I think you'll see that they're initially not quite as bad as you think. Because for instance, when I look at this arc sine, the arc cosine equation is the same exact thing with a negative. And if you remember when you took the derivative of cosine, what was happening anyway? You did a negative of what? So it's kind of easy to remember that, just negative what the inverse sine derivative was. And then I'll give some examples of these, but you'll see it's not a big deal. And then for arctan, right? That would be the arctan. Well, the derivative of the arctan. Well, the derivative of the inverse cotangent is the same thing as the tangent with a negative. And then same thing here with arcsecant. Arcsecant has a little drama surrounding it, but the derivative of arcsecant here, you have this absolute value, which is kind of an odd thing to talk about. But you'll see anyway, the derivative of the arc cosecant is the same equation with just a negative. So all of the derivative of the arc cos, whether it's cosine, cotangent, or cosecant, are just the negatives of these. But when you get to the AP test, and I have done a lot of AP tests, taken a lot of them, I have never seen anything except these two. And when I see these two, they're very simple problems that usually are associated with them. Are y'all with me? Now I'm going to show you a couple of proofs. For one, I kind of think they're interesting, and the algebra, the little proof of them is kind of clever, but I'm not going to make you know the proofs. I have at times put one as a bonus, and I'll say, hey, show me the proof of this, and if you happen to remember it, great. If I happen to show that as have that as a bonus question, that'd be awesome. But I'm not going to get into the proof on a test unless it's a bonus. So real quickly, let me just show you the proof of why this is what it is. And it's fairly involved, but again, just look at it. My goal is for you to kind of look at it at the end and go, that makes sense. Not to go, oh my gosh, how am I going to remember that? All you have to do is remember this equation. And literally, all you're doing here, they're using u to stand for u might be x, might be 4x, might be 4x minus 6, might be some crazy function in there. But the derivative just says the derivative of an inverse sine of blah means all you have to do is take the square root of 1 minus whatever is there squared, and then just take the chain rule then says multiply, which is why it ends up on the top, the derivative of that. So technically, this would be the formula. With the 1 on the top, you basically do square root of 1 minus whatever you have there, just bring it over there and square it. That's the derivative part, and then the chain rule says now go back and take the derivative of the u. Except people don't usually write times u prime, they just put the u prime on the top because mathematically that's where it ends up. And then the same thing with this. The derivative of an inverse tan, you take whatever you have there and you go 1 plus that squared. That's it. And then the chain rule says go back and take the derivative of that u and put it on the top. That's it. And this one's the same thing, except this one's a little more annoying because you have to take the absolute value of that out front, and then it kind of looks like this one, but instead of being 1 minus u squared underneath, it is square root of u squared minus 1. And then again, derivative on the top. Are you with me? So I'm not going to lie to you and tell you that it's fun to memorize these. It is. It's 6 more derivatives, really 3, and then negative, negative, negative. It's more derivatives you have to memorize. And honestly, I really don't think the proof is going to help you. I will be honest, every now and then I'm taking an AP test, and I'm trying to see how I would do, like in your position, and I'll hit one of these, and I'm like, crap, I forgot my derivative rules. But I remember the proof, so I'll take a minute or so and actually whip the proof out and go, there it is. And then I'll use the derivative, but most people aren't wired like me. So you probably don't have the interest, you're never teaching it, so you're never really learning it. You don't have to learn it, so it's kind of like one of those, I don't know, most people just aren't interested in proof. There might be a couple of you out there that are. I think everybody's capable of it, but I'm just saying, most people don't care about the why as much as I do. I kind of like to know the why. For whatever that's worth, just take a look. So let's just say I want to take the derivative of this. Like I have this equation, y equals arc sine of u, and I want to take the derivative, but I don't know it. So I'm going to use what I do know. And what I do know is, and you probably remember this, like if I have something like sine of an angle equals, I don't know, if that's true, then isn't theta equals inverse sine of that also true? Y'all know that relationship, right? Well, if I'm starting with y equals inverse sine of u, then what shouldn't also sine of y equal u be true with that same idea? Okay, so let's go with that then. That is a sine equation, and I do know how to take a derivative of sine. So what's the derivative of sine of y? Nope, not anymore. Times dy dx. So the derivative of sine of y is cosine of y, and then we learned yesterday, times dy dx. Because I'm ddxing both sides. You go with me? That's why we had to wait for implicit to show this. And then what's the derivative of u? 1 du dx. Now, I could leave that du dx in there, but it's kind of cluttered up right now, so I chose to change it back to u prime just to make it not look quite as nasty right now. And I think we all are okay about the u prime because u is like the blah part. And in the end, I'm going to have nothing but x's on one side anyway, so it's kind of like an explicit in the end, even though right now I'm dealing with it implicitly. All right, you tracking with me? All right, so I'm going to replace this du dx with u prime just to make it look a little pretty. So as of right now, I've got this. Cosine y dy dx equals u prime. Now my goal, like it was yesterday, is to solve for dy dx, right? So I'm going to divide both sides by cosine y, and that cancels. And now I have this part. Well, great, and that's okay and all, but again, I'm trying to take the derivative of y so that I have nothing but just like an explicit situation over here. So I really don't like that y there. I'd rather have something with x there. Well, the great thing is I have other identities that relate sine and cosine. So I just pulled out a Pythagorean identity, which is true, right? We all know this Pythagorean identity is true. And if I solve for cosine y by subtracting sine squared and then square rooting both sides, I get this, don't I? Yes, no?
Yeah, maybe so.
Okay, so I take that and I replace cosine y with it. And now I'm to here. Are you seeing this? Okay, now, sine of y from the original problem was equal to what? U. So I'm going to replace sine of y with u, and that gets me to here. And if the derivative of y with respect to x is this, and y is arc sine of u, then the derivative of arc sine of u with respect to x is that. Now, for u, all you have to do is apply it. So what you might see is, hey, y equals inverse sine of 2x minus 1. What is dy dx? So according to your rule, what does it tell you to do? Identify the u, so your u is 2x minus 1. It says go over here and go 1 minus the u squared. I take that u, I put it in parentheses, and I square it. And then what? Take the derivative of it, which is 2, and put it on the top. And I would be done right now because simplifying is not super important on the free response part. But if it was a multiple choice part, that may or may not show up. So if it didn't show up, just look at your multiple choice. Maybe they FOILed that out. Like maybe they said, all right, that's a 4x squared minus a 4x plus 1. And maybe they distributed that, maybe they distributed that negative in and ended up with 1 minus 4x squared plus 4x minus 1. Maybe they ended up with this. Are you seeing that? I mean, I doubt they would do this, but is it possible that this is also true? Take a stare at it.
Yeah.
Now, again, AP sometimes is dirty. This doesn't really feel like something they do. I think they'd probably leave it like that, and honestly, it's possible they even leave it like that. But you have to just be aware and don't jump the gun. Don't see something like this and go, oh, that's it. I mean, really make sure you're looking at stuff and not just getting excited to grab a letter, because sometimes they're a little dirty, sometimes they're not. But the actual derivative itself is not hard if you know your rule. And if you don't, you're missing it's probably going to show up maybe 2 or 3 points on the test, tops. I guarantee you it'll show up for one question, which is like 1.2 points on a free response, on a multiple choice. But every now and then you'll see a couple, and when it does, it's like, man, it's like taking candy from a baby, as long as you know your actual derivative rules. All right, let me show you one more. Look at the invert, and then we'll do some more problems, and some more stuff from yesterday. And those of you that weren't yesterday might appreciate that if you haven't bothered to check the video. If you haven't checked the video out and you weren't here yesterday, please do that. It is really an ultra critical topic. It's really, really critical that you understand implicit differentiation. Okay, so look at this arctan. Again, I don't know how to take a derivative of arctan. So I'm going to rewrite it in terms of something I can. I'm moving it over, making it tangent y. So now, what's the derivative of tangent y? Secant squared y dy dx. So derivative of that, secant squared y dy dx. And what's the derivative of u? Du dx. And to make it look a little prettier, since in the end it's going to all be some explicit equation, I went ahead and changed du dx to u prime just for the sake of pretty. Okay? That leaves me this. Secant squared y dy dx equals u prime. So I'm going to divide by the secant squared, and when I do that, that gives me dy dx equals u over this. So once I divide it out, now I'm here. Now, on this particular one, I didn't have anything given to me with secant, like before. Before I didn't have anything given to me with cosine. But I do have a tangent. So is secant and tangent related? Sure they are. Tangent squared plus 1 equals secant squared y. So I can replace the secant squared y with that. I don't even have to do any solving this time. So that goes in there. And then, what is tangent y? It's u. So I can replace that tangent y with a u. And now I have my identity. And then just to make it look prettier, since y is that, I'm going to go d that dx equals this. So d that dx equals that. But again, what's that mean to you? If I give you y equals arc tan of 5x squared minus 3x, and I say, hey, what's the derivative? What are you going to do? You're going to identify the u, right? And go 1 plus that squared, and then what? Derivative of that, which is in the numerator. And if that's not an option, maybe you clean it up a little bit. So you can see the derivative of these, they are not complicated. But it's really nice. You're going to see in related rates, which we're about to start, there are a lot of problems that will have like sine and cosine in them. And if you leave them with sine and cosine, you're like, oh man, this is some really ugly derivative that's going on here. But if you flip it over and turn it into an inverse sine or an inverse tangent, the actual math ends up being super easy. And sometimes I forget to do it. In fact, I never thought to do it until about 4, 5, 6 years ago, whenever a student goes, I just use inverse to sine. And I'm like, oh, think about it for a second. If I gave you a cosine equation, like, I don't know, and you had something like x, y over here, you're going to have to do what? Negative sine theta, d theta, dt, and then you're going to have to go first, d second, plus second, d first, and you got some math, right? So in the end, if I'm trying to solve for this, you got to go back and find the sine of the angle, you got to go plug it in, you got to do all these other values. But if I would have just done this, inverse cosine, I got an inverse cosine formula. So for me now, to take the derivative of both sides, I can just pull out my sine formula, which is 1 minus that, right? And then the derivative of that, whatever the derivative would be, which would have to do a product rule. And then what do you do for a cosine? Negate it?
Should be x times y squared.
Oh, sorry. Are y'all with me? And notice I didn't have to find the cosine of the angle. I didn't have to do a lot of different things because I knew this inverse cosine. It's one more thing in my arsenal that I have. And you'll see that directly because we'll spend a number of days on related rates like we spent a number of days on optimization. Because there's a lot of different ways we can look at that. Some of them are really tricky. Some of them aren't so bad. And the AP questions on related rates when we get there really aren't bad. They used to be awful in the 70s and 80s and early 90s, but they quit being awful a while ago. Y'all seeing this? I'm not going to bother with the arc secant. I do want to talk about this though. In this proof, okay, and not that a whole lot of people care, but in the proof for the inverse secant, or the arc secant, you get down to here and you're like, why does this suddenly become an absolute value? Like, why does it do that? And I actually was curious about that because I was like, why does it magically just do that? So I started researching it, and literally I kept on getting this comment or something like it. It kept saying something like, there is no common agreement on the definition for blah or blah for negative values of x. When we define the range of the blah, the blah, 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 and at some point my brain just kind of turned off and I'm like, really? But literally textbooks keep saying this, and I just came down to this. Just remember, it says you will need to know how to prove these. That is no longer true. I do not need you to do that. But anyway,
You can ask Gabe.
no, I've asked more than Gabe. I've asked college professors. But tutor Gabe, and although Gabe is a pretty smart dude, but I've asked a bunch of guys this, and every one of them's like, yeah, you know, there's a lot of disagreement. I was like, I know, I've already heard this story. So, but anyway, for whatever that's worth, I don't have a good sound answer for why that's absolute value, except it needs to be when you're actually doing the math. But on the AP test, it won't matter because they don't ask about secant and inverse, the derivatives of inverse secant or inverse cosine. Are you with me? Okay, so moving on, I want to do a couple of practice problems, but I don't think that you're going to. I don't think that you're going to have any issues with this. So just a couple more, maybe. How about? And a lot of this is really just the algebra I want you to see. But like, what if you saw f of x equals arctan of the square root of x? What is the derivative of f? So clearly this is written in explicit form. This is what we're accustomed to seeing. So f prime of x is fine. If you want to write df of x dx, that's fine too. How do you take the derivative of an arctan?
U prime.
So I'm going to take the derivative of that on the top. How do I take a derivative of radical x?
It's the derivative over 2 times the.
So double that on the bottom, and then the derivative of the x, which is 1 on the top. And then what goes in the denominator here?
1 plus c squared.
1 plus that squared, and what is root x squared? So let's clean this up. I have 1 over 2 radical x divided by 1 plus x. How do I do that? Because it's not going to look like that on a multiple choice question. Do what? That's what I would do, but you're really doing what? Yeah, you can do that too. Yes, you can do that. I said yesterday that if you ever have a fraction within a fraction, look at the fractions. There's one number. It has a 2 root x denominator. Those have a 1 denominator, so I'm going to multiply the top and the bottom by 2 root x. Right? And what happens? That cancels and leaves me a 1, and I get 2 root x, 1 plus x. That's fine. What you were saying was drop it to the bottom. He was saying basically take that part and move it down, but isn't that the same thing as saying to divide by a number, I multiply by its reciprocal, which puts all of that together? Regardless, it's going to look like that, not like what you saw originally here. Let me give you another one. What if I had something like h of x equals x squared, get away from tan, about arc cotan of x. What do I have going on here? I have a product rule, right? That times all of that. So for the derivative, first, now what's the derivative of the arc cotangent? So negative that, the derivative of that, right? What's the derivative of the x? So negative 1 over that squared. So all I end up with on this part is negative x squared over 1 plus x squared. And then first second plus second times d first. 2x, and most people don't leave that 2x out to the side, so most people write 2x arc cotangent of x. And that's most likely how you would see that. It's possible the negative's up front or whatever. It's possible it's that minus that. You all with me? So I don't know how to make this uglier. I mean, except maybe making a product rule, quotient rule, some other kind of rules, but the actual derivative part itself, you just have to know the derivative, and it usually is not bad when you see it. And if you just remember them, you can really bail yourself out a lot of ways. If you don't, every year people go into this AP test with, they don't have this memorized, and they don't know how to do the problems we're talking about tomorrow. Tomorrow, the thing I talk about is arguably the most forgotten topic ever, and it's only going to cost you probably 3 or 4 points. But again, if you keep giving away 3 or 4 points, pretty soon you've given away your 5, and then you've given away your 4, and then you're worried about getting a 3. And at some point, you just got to learn them. And the upside is, it's not hard to do the problems associated with these. Yeah.
What is the most common problem on the AP exam?
Oh, I don't know. You're always going to see, like on the first couple multiple choice, you're always going to see find the limit, and it's some basic limit rule, or find the derivative, it's some basic derivative rule. There's always some freebies.
Which area has the most points associated with it?
Differential equation. There's always a 5 to 6 point differential equation problem. Every single year in my memory for the last 15 years or so, 5 or 6 point differential equation problem is always on there. And usually the stuff that's associated with it are give-me's as well. And there's almost always an area and volume question about area under a curve, or the volume when you rotate a curve around an axis, which sounds real complicated, but my class averages on those tests are A's. That's always on there. This past year it was not on there because they just said, hey, we're not going to cover area and volume, which stunk for us because on March 13th we were finished with the curriculum. And area and volume is the easiest stuff. And they just said, we're not covering that because some schools didn't get to it, which stunk for us because that was what we were excited about. It's like a gimme 9-pointer. But those two topics are on them all the time, and they're big chunks of points. All right, guys, let me go back. If you think you have this, anybody got any questions on this? The bottom line is you're going to have to know these formulas. If you want to jump with me to, I just want to do a couple more problems with stuff from yesterday. So there were some really good problems, even better than I thought, on the homework. If you didn't do the homework, then you're missing some stuff. Some of them are a little bit harder than I would test you on.
A little bit tricky.
Yeah, they were. And I was speaking with somebody this morning about that, just looking at some of the topics. I'm like, ooh, that's pretty good. But they're great practice for making sure you're going to be in good shape on your test. So all those topics might be on the test. Sometimes the level of difficulty is not as tricky, but it's good practice. If you're skipping those, you're really hurting yourself because this test will have some of this stuff on it. So let's walk back through it again. It says, write a general expression for the slope of this curve. So I'm looking for what? The dy dx, right? Because this is an x and a y axis equation. So how would I ddx both sides here? Right? I'm going to ddx that and ddx the 9. So how do I start out?
2x.
So derivative of x squared is 2x. And then how do I deal with the negative xy? I'm going to treat it as positive negative x times y. So I'm going to go plus and then start my product rule. So first,
Negative x times dy dx.
times dy dx, or 1 dy dx if you will, and then plus second
Y.
derivative of the first.
Negative y.
And then finish up with a plus
2y dy dx.
dy dx, yep, and then equals 0. And then like we did yesterday, we want to solve for whatever has a dx in it, or solve for the dx. So I'm going to look for the terms that have a dx in it, and I'm going to move everything else over. So I'm going to move this 2x, it does not have a dx in it, right? That's going to go to the other side and become a negative 2x. I'm going to take this, so that gets moved over. This negative y becomes a positive y over here. So now that's gone and that's gone. And then in one step now, I'm going to do this. I'm going to factor out the dy dx. And if I did, what would I have left? Negative x plus 2y. So I would have a negative x plus 2y there, and then I would divide both sides by a negative x plus 2y. And I would probably write it like that instead of negative x plus 2y, but whatever. And that's I answered the question. That is a general expression for the slope of the curve. Yes?
When you move the y over, why is it positive? Shouldn't it be negative y? Because it's y times negative 1.
So it's negative y now, so I'm going to add y to both sides.
If all my lines are flipped, will it be wrong?
What do you mean?
Like, I think I got 2x minus y over x minus y.
You got 2x minus y?
I got 2x minus y.
How is that possible? Mathematically, it would be right, but algebraically, how would you get that? Because I'm subtracting 2x from both sides.
If you, I guess I moved everything over to the, I moved the dy dx to the right.
Oh, well then that mathematically is okay.
Okay, okay.
If you move the dx's over it, I don't know why you do that, but it's right. I normally would just subtract it over and leave those there. But yeah, technically, if they both are, if that's opposite and that's opposite, that's like multiplying the top and the bottom by a negative, which is fine. It says find the coordinates of the points on the curve, on this curve that I have no idea what it looks like. I mean, really, I have no idea what that looks like. It could be all kinds of weird stuff. We talked about this briefly in my pre-cal math class, the pesky xy term, and what that does to stuff. This could be a tilted ellipse, a tilted hyperbola, it could be a pair of parallel lines, it could be other weird stuff. We have no idea without some serious math to substitute it in there and figure it out. So I don't care what it looks like, but the question says find the points on the curve where the tangent lines would be vertical. Now where would a tangent line, what characteristic of a tangent line would make it vertical?
The denominator of 0 would be 0.
So the slopes would be undefined, and the slopes are undefined when the slope has a 0 denominator. So I am going to take that denominator and set it equal to 0. Now some people have a real problem with this, because yesterday when we set it equal to 0 and solved, we got a number. And that was nice, right? We got something like x equals 3. And we took that 3 and we plugged it in for x and we solved for y and we had a big smile. But now I don't have that. I have 2y minus x equals 0. But guys, I am solving a system. That is an equation. That is an equation, right? I want to solve that system. So what would you do to solve that and that if it was a system? You'd probably say 2y equals x, right? And then just plug the 2y in for x everywhere?
Yep.
Just do that. So don't make it hard. Everybody with me? Everybody?
Of course.
I mean, everybody? Okay, so 2y goes in for x here.
Sure.
Stay with me, guys. And by the way, you could say y equals x over 2, but why make it harder on yourself? You know, I'd rather not have fractions if I don't have to deal with them. So I'm going to plug the 2y's there and there. And I bet this works out nicely. So I get 4y squared minus 2y squared plus y squared equals 9. And that gives me what? 3y squared equals 9. So y squared equals 3. What does that mean then? Y equals plus or minus root 3. And if y equals plus or minus root 3, where would you, if you're solving that system, where are you going to plug a plus or minus root 3? In there? I'm going to plug it in there because it's just easier. So that means that my x would equal twice that. So twice plus or minus 2 root 3. Now don't write your answer like that. You got to be careful. What it really means is when x is root 3, if I plug a root 3 in there, when y is root 3, my x is what? Positive 2 root 3. And when y is negative root 3, x is negative 2 root 3. But make sure that these coordinates, it says find the coordinates of the points, so those are the coordinates of the points. You're welcome to write them as a point. If it said find the points, I would have written them like this. 2 root 3 comma root 3, negative 2 root 3 comma negative root 3. But either way is fine. They kind of gave you some flexibility when they said coordinates, because they didn't really say write it as a point. Are y'all with me? Okay? And then on part C, it says at the point 0, comma 3, says find the rate of change in the slope of the curve with respect to x. Now this is your first glance at AP starting to get a little dirty with you. It kind of looks like they're saying find the slope. But what did they say? The rate of change of the slope. The rate of change means slope. So rate of change of slope means slope of slope. Are y'all with me? That is a very common thing. You're going to see that again and again and again. So at first glance, you're like, oh, they would have got me there. Probably got me too. But after a while, you will begin to get immune to that. So read carefully, but rate of change in slope is slope of slope, which is the second derivative. So I'm going to go back, take my first derivative, which I have there in red. I'm going to keep that. And then find the second derivative. Now, remember how to do second derivative. d2y over dx2 is what? Get me started. Quotient rule. Low.
Low D high.
D high. Now, how do I take the derivative of that top part? 1 dy dx, or just dy dx, minus 2. Now again, it's the whole low part. So I'm going to put a big bracket and go low. All of this is a d high. So, no, I guess I'm good right there. Sorry. And then minus what? High, y minus 2x times
D low.
And the d low would be 2 dy dx minus 1. And all of that is what?
Over 2y minus x.
All right, now here's where you need to use your good common sense. This was an old 9-point AP question. 9 points, which means if you were able to just do the first 2 questions, you would have just gotten 6 of the 9 points. This would have been a shockingly simple way to get points. on this AP test. And by the way, if you can get 6 out of 9, you're well on your way to a 5. So literally, 6 out of 9, you're good. 4 out of 9, you're well on your 4.5 to 5 out of 9, you're well on your way to a 4. And 3 out of 9, you can usually eke out a 3. And they're typically, and you'll see a couple of questions that are very common and you'll be very, very prepared for. So getting 7, 8, 9 out of 9 is not going to be overly difficult unless you make it that way. So here's my formula. Now, notice the question said, it did not say, find the general equation for the rate of change in the slope, did it? It just said, find the what?
Rate of change.
The rate of change at that point.
Plug in 0, 3.
So I am not gonna bother like I did yesterday, writing a special equation with that in place of the dy dx there and there. I'm not gonna do that. What I'm gonna do, and that's what I would have told you to do yesterday, right?
Right.
But I didn't ask you for that general equation. So I'm gonna find the rate of change in the slope at this point by, how do I label it again? Vertical line at 0, 3. And here's what I'm gonna do. I'm gonna plug in the 0 and the 3 everywhere I can, but what am I gonna do when I get to this?
Just plug in what it would be.
I'm gonna plug it in there. So I'm gonna make sure that the AP reader sees that. Out to the side, I'm gonna go, hey, by the way, the slope at 0, 3 is 3 minus 2 times 0 over 2 times 3 minus 0, which is 3 over 6 is a half. And I'm going to use that 1/2 because you probably get a point for that. So really label that nicely. I'm going to use that half every time I get to this, because this is the slope at 0, 3, just like the second derivative is at 0, 3. Are y'all seeing this? That saves me the trouble of plugging that in. But if it had said general equation, then I would have plugged it in. But I'm always looking for ways to try to make my life a little bit easier. So here we go. Be really careful and show your math here. 2 times the y
6.
minus 0 times dy dx 1/2 minus 2 minus 3 times 2 times 0 times 2 times dy dx minus 1. All of it over 2 times 3 minus 0 quantity squared. And at this point, it's just cleaning it up. So I get a 6 times a what? What's a half minus 2? Negative 3 halves. And then minus a 3 times what? Well, that's great. 1 minus 1 is 0, so all that goes away. And then all of that is over a 6 squared. So fortunately, all that left side went away. I can cancel that 2 with that 6. And I get negative 9 over 36, which is negative 1/4. And you would get points, probably, you've already gotten points for the red part in problem A. So you would get a point for acknowledging that that was a 1/2. You would get a point for using the quotient rule, and then a point for making your substitution in here. And then you get a point for your answer. So this very well could have been a 4-point problem, the 4-point section. But probably 3 to 4 had they been doing it this way. Now, I'm going to be honest with you, they're not going to give you that many points on an AP test for a question like this anymore. 2 or 3 tops, but they're not going to give you like A, B, C on the same thing. This is just not a 9-point question by today's standards. Y'all seeing this?
Yeah.
Not too bad? All right, this is an actual question from that question was from 1978. And the reason why I'm using these old questions is there aren't any 9-point new questions. But these were old 9-point questions. 1992, gosh, I was in grad school, about to finish up college. To finish up my master's. REM was big.
What else was going on?
What else was going on? Clinton just got elected. Bill. What else was going on in the 92? I don't know. I was a lot younger.
That was when Columbus.
Yeah, Jordan won his third. That was what?
In 92?
Oh, yeah. Okay, so this is 1992. This is number 4. This was a 9-point problem. Usually when there's an ABC, it's 3, 3, 3. Occasionally they change that because, like, if everybody in the country got absolutely smoked by C, they're like, you know what? Let's make this a 3, 4, 2, and that way we can count it less and the scores aren't as bad. So they do it. They never tell you. You have no idea how many points are worth what, other than maybe learning from past experience. But every now and then they'll do that. They're like, man, we creamed everybody on this. This can't be 3 points. And they'll switch it to 1 or something like that, just to make the scores better. But anyway, you only know that after the fact. So here we go. Consider the curve, find the derivative in terms of y. So for part A, what's the derivative of that? Help me out. dy dx plus, what's the derivative of cosine y? Negative sine y dy dx equals 1 plus 0. And then how do I solve for this? If I factor out a dy dx, what's left? 1 minus sine y. So I'm going to divide 1 by 1 minus sine y. I don't know if that's 3 points. That's probably, but it very well could have been. They might have said, check the, did they do the derivative? Did they mention the dy dx? Did they solve for dy dx? Yes?
Why would it be sine of y and not just sine of 1 times dy dx?
Yeah.
It's not x, y squared.
Because you have to do it for the tangent and then for the derivative of the whole.
Oh, yeah.
What now?
Never mind.
You good?
Yeah.
Everybody good? Okay. Now that's A. I did the derivative in terms of y. Write an equation for each vertical tangent to the curve. Now what did they asked for what? Not the points where they existed, but an equation of that. Now here's the nice thing. What are equations of vertical lines?
Constants.
There's always x equal a constant, right? So really it's like finding the point, but all you need is the x coordinate of that point, right? So once you find the x coordinate, you can just go, because that's a vertical line, just like a horizontal line, all you need is the y coordinate of the point it went through. So you don't even have to worry about the whole equation of a line thing like you normally would. All you need is that point. So for part B, write an equation. So I want to know where what? If it's vertical, it's an undefined slope. When is that 0? So for part B, I'm going to take 1 minus sine of y equals 0. On the free response, I'd probably say that vertical tan lines occur when dy dx is undefined, or dne. Therefore, 1 minus sine y equals 0, or sine y equals 1.
Do we need to write this on your test, or is it?
I always write the calculus part because you never know what they want. They may or may not want it, and they're not clear about it. So most people have a couple extra seconds to say why they did it. Now, if they say justify your answer, then you can say why you chose it. But I get in the habit of doing that anyway. It doesn't take much more time, and if you know your stuff, you can still get done and have time to spare. Whatever. But it depends. You'll start seeing later on in the year how things are. I say how they're pointed out, how they give points.
Do we need to say vertical lines?
I would probably give you a point for that and a point for answering this, solving this equation. So where does sine, this stands for an angle, right? Sine of y, right there, sine of the y. Y is an angle. At what angles does sine have a value of 1? Except we don't use degrees in calculus. So pi over 2. You got to make sure you're aware of that. So right here, at pi over 2, that's true. Okay? Are you with me? Now, the vertical tangent line occurs when y is that. But that's a horizontal tangent line if I just leave it like this. I need the x coordinate, don't I?
Yeah.
So how do I find the x coordinate?
Plug it back into the original equation.
Plug it back into this to find x. All right? So I'm going to plug it back in there and go, all right, pi over 2 plus cosine of pi over 2 equals x plus 1. Pi over 2, what's cosine of pi over 2? 0. Subtract the 1. So at x equals pi over 2 minus 1, that would be the x-coordinate. Now, if they'd asked for point, I'd give them this, but they didn't ask for the point, right? They asked for the equation of the vertical line. And again, vertical lines go through a point, but go vertically down through the x-axis, which means that my equation is the actual x-coordinate. Horizontal line would be y equals pi over 2. And that's true for any point. Y'all with me? And that's 3 points. And again, this is a rare thing. You probably get 1 point for making that connection, 1 point for solving that, and 1 point for solving for x. That's probably how they had pointed this if I were to go back and look at 1992, which I don't even know if they have the scoring guidelines going that deep. I might have them somewhere, but I don't know that they're still on their website. And then C says, find the second derivative. Well, the first derivative, if I remember correctly, was 1 over, what was it, 1 minus sine y?
Yes.
So if that's the first derivative, what is d2y over dx squared? Low, d high, what's the derivative of the high?
0.
So I'm not writing anything. Minus high, which is 1, d low, what's the d low?
0 minus.
0 minus cosine y dy dx. Y'all with me on this? Low d high is gone, minus high, which is -1 right there, d low, which is 0 minus cosine y dy dx, all of it over the low squared. And since they said find that, what do I need to do in this case? Plug that in. They didn't ask me for the derivative at a certain point where I could cheat a little bit. I have to plug that in. So let's clean this up a little bit. These two negatives make a positive, so I went ahead and got rid of that. So I'm going to end up with cosine of y times 1 minus sine of y under the 1. All of that over 1 minus sine of y quantity squared.
Can't you cancel out a 1 and 1?
No.
Yeah.
Y'all with me on that? Be careful. It's so tempting to do that. That's the whole this mistake. Oh, that cancels. Because everybody knows if I have a half a pie and I split it between two people, everybody gets a whole pie.
Yes.
That doesn't make any sense, right? A half divided by 2, we all know is a what?
4.
Is a fourth. So when I look at this, again, my trick is I've got a fraction within a fraction. The denominator, the common denominator of all of those is a 1 minus sine y. I'm going to multiply by a 1 minus sine y on the top and the bottom. And when I do that, what happens on the top? So I end up with cosine of y on the top, and on the bottom, I just have a cubed now. And another way to do it would be to say, well, this times this just puts the cosine on top. And to divide by a fraction, I multiply by the reciprocal. And if I did it that way, I still get the same thing. So that is my second derivative, and make sure you label it. How y'all feeling? Good? What do they give National Market these days? You National Market?
Yes.
What do they give you extra?
Like, room and.
They give you room too?
I think so, yeah. And like a $3,500 stipend all 4 years.
So they give you room and board.
Yeah.
I mean, and tuition.
Yeah, and it's stipend and like Delhi food.
Yeah, that's way more than I
Yeah, they're right there.
Where is this?
Mr. Hurry, you're still recording.
It's cool. People at home want to see the vibe of the class, you know?
You know the atmosphere.
The atmosphere, see their friends.